Okay, so good morning, everyone. So the problem or the unresolved challenge I would like to talk today is what I call the out of equilibrium city. And so I'm coming more now from a civil engineering perspective. And so we probably all know that, like urban science has made tremendous progress in our ability to predict cities based on data. From an engineering point of view, we know how to predict mobility patterns, traffic flows, energy consumptions, and many other aspects of urban life. But there is still one fundamental limitation. And this is because our predictions, or the predictions that we make, are typically based on observation of a city in its existing state. But the most important question when we are actually trying to plan urban infrastructures are actually more related to understanding how those interventions actually change that very state of a city. So think of, for instance, about what happens if we build a new metro line in a city like New York City. What happens if we pedestrianize a city center? Or what happens if we introduce congestion pricing or rebuild an entire new urban district from scratch? So these are all very dynamical processes that are taking place. And so all these interventions, they change the very system that we are trying to predict, and that brings us in the dilemma that historical data is quite good at predicting the future of systems that resembles the past, but the most important decisions in urban infrastructure planning are those where we try to build a future of a city that is different from the past. And so we really lack of a general framework, I believe, that really helps us to understand how people, firms, and institutions really co-adapt with urban infrastructure interventions. And therefore, I believe it's a main challenge of the next generation of urban science approaches to build such a framework that really helps us to understand the urban dynamics and especially the intra-urban dynamics in response to deliberate changes in the urban systems. Thank you.